Okay, good morning and good afternoon to the third session, the mentorship program. Just a quick recap on the what we did in session 2 is actually we looked to the overall journey of the cloud. I mean, the evolution of the cloud and when was the first entry point of telcos embracing cloud. If you remember, we talked about 2012 in particular when the idea of NFV started to rise, and also we started to look from bottom top. Let me just admit, Viva. We started to look from bottom top. I told you before, we actually embrace any kind of cloud technologies, any kind of talks about the virtualization, containerization. We need to understand actually the infrastructure aspect or the hardware. And that's why we spent some time talking about the concept of CPU, sockets, NUMA, this kind of principles, hyper-threading, and the related concepts. So today, we are going to give an overview or cover NFV, the concept of NFV, Network Functional Virtualization, the role of HC. And also, we are going to a little bit talk about the cloud stack from a top bottom. We are going to discuss the concept of data center and have a little bit of an overview about the data center networking. Okay. Most probably in the coming sessions, we will go into details of some of the aspects of today's session. So let's start. We have 45 minutes, and I think we will finish on time today. So NFV is really one of the trending term. Anyone working on the telco cloud or working on the telco side, on the operator side, usually use the word NFV, which stands for Network Functions Virtualization. And if you talk to anyone, like any kind of IT engineer or any kind of having experience in cloud or virtualization, if you tell them NFV, most probably he will not understand you, because NFV, the term Network Functions Virtualization, is a very specific term that describes the virtualization in the telco domain or telco context. And the buzzword here for them is not virtualization. Virtualization, as we saw in the timeline, the concept was there from the 17th or even 16th. But the buzzword for them is actually the network functions. And it's a little bit weird because we as network professionals or telco professionals, we are very familiar or are very comfortable with the term network or network functions. But from an IT perspective, from cloud perspective, the concept of network really does not exist, because you barely see a concept of number of applications working together at the network to provide certain service in IT. It's not there. But in telco, in network, the concept exists. And that's why I always start with this slide, which looks very basic for network professionals, but it makes sense for people coming from IT, software development, to understand the concept. So mobile networks, data networks, whatever networks, it consists of multiple of network functions, okay, that together, we just admit Nisma. So these network functions with some sort of integration and interfaces or standard interfaces between these functional blocks, they all construct a network that actually provide a set of services or a specific service. As an example, the mobile network, the mobile data network that provide data service, the mobile voice network or the CS network that provide a voice service. So before we go to NFV, we have just to acknowledge that there is a concept of network function and the concept of network. And for instance, I give an example here of the classic 4G network that consists of multiple network functions or multiple function blocks integrated together via standard interface, providing the 4G service. The problem is that, or not the problem, the fact that if you want to build this kind of network in a classic way, okay, then most probably each functional block as a network function will be constructed in a classic way, and that means that you call, you do an RFP, you procure solution from vendor X, Y, Z, and you end up with some sort of a single stack that's actually a position in a chassis, hardware chassis, that includes a very proprietary hardware to that vendor and a proprietary software. But at the end, it is providing the logic of a P gateway or a BNG or a DRA or a MSC or any kind of network function. Formerly, as a telco operator or anyone working on telcos, we didn't care a lot about that kind of proprietary hardware or proprietary software, as long as the network function is giving you the logic or the function that you require. So you want to procure a P gateway in 4G, you get some sort of a chassis from Huawei, from Nokia, from Ericsson, but at the end, it provides the service of P gateway. And that was a problem identified by many operators because, for instance, I give an example of here of the voice over LTE. Okay, that's the voice over LTE service, where you provide voice service over LTE and not over a CS network or 3G or 2G. Regardless of that service, this is not a program about VoLTE or 4G or whatever, but to provide that VoLTE service, and VoLTE service is not a service that you can monetize exceptionally. Most probably the end users doesn't care a lot if it is VoLTE or voice over CS fallback or whatever, as long as they get the voice service, which is the calling service. But in order for an operator to provide a VoLTE service, he needs to build this kind of network, and that's a very simplified one, by the way. If you go to the 3GPP of the IMS, you'll find a very sophisticated reference architecture for IMS. So you need to build this kind of network functions to provide just VoLTE. And the fact is, when you start to do that, you'll get N vendors, many vendors, if you don't go for a single vendor, and you get N proprietary chassis. So you get a lot of chassis, very hardware proprietary and software proprietary to the vendor. You get a lot of racks because each network function is a separate rack. And the rack means more space, more power consumption. And in the old days, before 2012, and even if like people working on the start of the 3G and these kinds of things, the hardware itself was a very special purpose hardware in the sense that if you need a function like MSC, you get the hardware of the MSC. And that hardware is different from the hardware providing media gateway thing. So it's a very special purpose hardware positioned for a specific service. The project to actually deliver VoLTE, it's a very lengthy project. We suffered a lot, and maybe we are still suffering, but anyway, our projects in telco are very lengthy. You can take 1 year to provide a service. The racks itself, the chassis were very, very powerful, so they had a lot of power consumption and power requirements. And at the end, it's a time to market very high. You can even reach more than 1 year. And all that just to provide a service like VoLTE. And that was perfectly, I would say, didn't make sense. And that was all acknowledged by all operators that this is really one of the pain points of the telcos that used to be. Let me admit, Nita. And if you want to summarize the case, okay, of such setup or context, you will find that telcos have lack of agility in order to introduce one service like VoLTE. And again, it's not a fancy service, it's just an evolution on how you provide voice service to your customers. Okay, you have a complete lack of agility. You take like a full year to provide VoLTE. Growing CapEx, you are just increasing your CapEx, building chassis, proprietary chassis, racks, you're populating your sites with racks. So it's a growth in the CapEx. Hardware life cycle here, that was very significant because since you coupled the service with hardware, in order to provide service X, you need hardware X. In order to provide service Y, you need hardware Y. So every time you need to change a service, you change the hardware. And that doesn't make sense because the normal thing is actually services are being modernized and being innovated in a very short cycle. So it doesn't make sense that you change the hardware every time you change the service. The fourth thing, and here the colleagues, you may note that colleagues working on the operators and even in the vendors, that there is a skill set challenge. What does this mean? That if you procure a stack from vendor X, most probably the services to deploy that stack will come from vendor X. So you pay them a lot of service to fulfill the stack. If you go for Nokia, for Huawei, then most probably you'll get service from Nokia and Huawei, and this makes perfectly sense. But at the end, the operators felt that they are obliged to work with the vendors and get service with a high price to fulfill their stacks. So what we concluded from the last slide, and I put it here in 4 points, that was exactly what was mentioned in the NFV white paper that was introduced in October 2012. So the operators, big operators by that time, AT&T, NTT Docomo, and Orange Group, I guess, and Vodafone and Deutsche Telekom, they mentioned explicitly that these are the pain point that we have, and that they believe that embracing virtualization and cloud principles would help the telcos to overcome or to provide solutions to tackle these kind of pain points. And they invited all vendors to come and participate, okay, to create a solution for telcos somehow to use virtualization techniques and cloud techniques to counter these pain points. And just right after issuing this white paper in October, NFV, HCNFV, European Telecommunication Standardization Institute, was chosen to be the home of NFV, and they built the NFV ISG, Industry Specification Group. And since that time, HCNFV is the home of standardization for NFV, for Network Functions Virtualization, or we can call it, like as a marketing term, the telco cloud. And what you see here is just an informative diagram. We are going to cover that later in the program. Is that HCNFV started to, let me just admit Fatin. HCNFV, they came with the reference architecture. And why did they do that? Because they know that telcos love reference architecture. You cannot find any kind of 3GPP or standard technology in mobile communication without a reference architecture. So they came with HCNFV reference architecture that most of the telco operators by that time took it as a reference and started to build the telco cloud based on that reference architecture. So that was the kickoff, and that was the entry point for HCNFV. Those were the pain points that the operators declared and used to build the concept of NFV. I will just put another slide, and then I will open space for questions. And that's the concept of the NFV, that instead of having network functions running on their proprietary hardware, having their own proprietary software, let's have the same NFs, network functions, on a commodity hardware, something like the IT servers, and using the virtualization techniques, okay, to make them running in a virtualized environment. Instead of having dedicated hardware, the service itself, the VNFs, will be very decoupled from the hardware. They can run on any commodity hardware, and they can all share the resources of that hardware. And going forward, having that context, the network function will be VNFs, will be virtualized network function, because now they are running on a virtualized environment. So that's the classic concept, but for sure HCNFV provided more like reference architecture, functional blocks to actually deliver value to whoever using the stack. So it's not just about putting DNFs on a hypervisor or a commodity hardware. We will see in the program that there are more advanced principles, but that was the core concept of NFV. That NFV offers a way to design and deploy network services by decoupling the network function from proprietary hardware. And having these network functions running in a software environment, which is the virtualization. And once you do that, you get the term VNF, virtualized network function. So instead of P gateway, it will be virtual P gateway. Instead of MSC, then you get virtual MSC. I'll stop here. If you have any questions, please feel free to ask. If not, I can continue. Carlo, you made a very good point, a historic point, that before that there was the initiative of ATCA, people who have like worked in the early 2000s. So most of the vendors, they provided an ATCA platform that can be used as a general purpose hardware for different software. But eventually you got Nokia ATCA, Huawei ATCA, Ericsson ATCA. So the concept was there, but it actually it was like it moved to practical situation or ecosystem with the NFV. Any questions?
But Karim, for now that you mentioned the ATCA, I remember it was like HP servers, right?
No, actually, ATCA was not just HP server. Maybe in case of Nokia it was, but because by that time I was working in Nokia and then I moved to Huawei. So you always get the term of like vendor X ATCA, like Huawei ATCA, and you're not sure actually who is maybe it's an HP but labeled by another vendor. But the concept itself didn't succeed because at the end it turned to be a vendor proprietary stuff. Yeah, and even if HP was there in the stack, but you don't get the name of HP. It was like labeled by the vendor X product.
Okay.
Hello, Karim. Sorry. Did they have like a time? I mean, for how many years was used ATCA? Just for the concept, or did he have like in the market like 1, 2, or 3 years?
See, ATCA, we saw the evolution of ATCA with the evolution of the packet core. So it was like booming. The concept was booming with the late 3G and early 4G. So from 2008, for instance, okay, to 2012, most of the platforms were ATCA.
Okay, thanks a lot.
Okay, Karim, this time, just I have one question related to the radio network. يعني, here for the NFV, most of the technology used behind the core network. But what about the radio network? Is there any way for the virtualization similar to the core?
Okay, so HCNFV, they avoided saying what are the network functions explicitly. So they didn't say that's for the core function, that's for the BNG, that's for whatever. They said this is for the carrier grade or telco workloads. Okay, and there is a famous question in the HC wiki, or frequently asked question. Someone's asking, is HC NFV only for telco workloads? And the answer is no. It's for all workloads that require this kind of carrier grade performance or stability. So by that time, the virtualization was mainly on the core because the technology evolution of the products were only focusing on the core. So you might remember that the first generation was the virtualized EPC or the virtualized gateway. And that was a standalone, that was an application on a standalone server, virtualized, but on a standalone server. The radio, when we started to embrace the new technologies like Cloud RAN, vRAN from the vendors, then virtualization started to hit this border. And now with the O-RAN, for instance, we will cover that in the program, having this kind of segregation and having this kind of CU and DU separation. So this CU and DU now are 100% virtualized and containerized applications. So during that time, the focus was only on the core because that was the network functions ready to be virtualized. But now the virtualization is in everywhere.
Great, thanks.
Okay, so it's hard for me to look to the chat. So if you have questions, maybe you can just ask me. So we agreed that in 2012, NFV is leading the standardization. So they had to come up with a reference architecture. Why? Because they know that we telco people, telco tribe, we love reference architecture. We love to see functional blocks integrated to each other with a standard interface and understand what kind of protocol. This is how we interpret the technologies. So they came with the well-known, famous NFV reference architecture. And NFV reference architecture, it has like two parts. One part which was very important, very popular, which is called the MANO, NFV Management and Orchestration. And other part is like a logical representation of the elements that construct the cloud stack on the telco environment. So I'll just scan these names, but we are going to cover that along the program. So NFV introduced some set of like functional blocks. Let's start from bottom top. Okay, bottom top. So if you see my cursor, I'm not sure if you see it or not. You see it, right?
Yes, you can see.
Okay.
Yes.
So we have the hardware resources, compute storage network, which is classically the infrastructure. Okay, this is like pure infrastructure, servers, CPU power, disks for storage, network like the data center networking. So this is the hardware resource. And the logical representation is telling you that whenever we put a kind of virtualization layer, which maps to what the concept of hypervisor, we will have this hypervisor concept in the program, you get, instead of compute, virtual compute. Instead of storage, you get virtual storage. Instead of network, you get virtual network. So that's just a logical representation of adding the virtualization layer or the hypervisors to the infrastructure. And when you get that, you get virtual resources. Okay? And they called this domain NFVI. NFV infrastructure. NFV infrastructure. And if you look to the definition of NFVI by that time, so NFVI was the totality of hardware and software that construct the environment that hosts the network functions. So it is the hardware resources plus the software resources, which can be the operating system and the hypervisor and whatever above that, that create the environment to host the application. And for that NFVI, okay, we call the NFVI like, this is like one like execution environment. So any kind of environment, they need to have a controller or an orchestrator or a management layer that manages environment. So they come up with the concept of VIM, virtualized infrastructure management. So that's the brain or the controller that manage the NFVI. So what fits to VIM? Solutions from OpenStack, for instance, OpenStack controller, that's the VIM. VMware controller, that's a VIM. Any kind of controller to the hardware, for example, any kind of solution coming from Dell, from HP, all these can be part of the VIM. But again, I would like to stress that these are NFV terms. Like if you go to an IT professional or a cloud even professional, AWS professional, and you tell him, what is the VIM here? He will not understand you. This is not a cloud community term. That's an NFV standard term. Okay? So VIM and NFVI. So NFVI, that's the infrastructure, hardware and software, and VIM is the manager for that NFVI. Okay? Above NFVI, what is actually onboarded, we use the term onboarded. What you can onboard in that NFVI, you onboard the network function, the telco network function, right? And because they run on a virtualized environment, they get the term VNFs, not NFs. So you get VNF1, VNF2, VNF3. And when you go to that level of onboarding VNFs, you start to have also a manager for that VNFs. The same way you had the VIM for the infrastructure, you need something on the VNF level to manage the VNF. And when I say manage the VNF, we use the term manage the lifecycle management of the VNF. You will always hear that term, the LCM. What is lifecycle management of the VNF? The way you instantiate the VNF, the way you actually turn it on or onboard the VNF on the infrastructure. The way you scale the VNF, for example, when you have big demand, high throughput, whatever you need to scale your VNF to cater for the new increase in traffic. Okay, how you upgrade your VNF, how you patch your VNF, and eventually how you terminate your VNF. So all the things gathering the VNFs from the time of instantiation till the day end operation or termination, this is what we call the LCM. So each NFV suggested the existence of a block called VNFM or VNF manager, and that was responsible of the lifecycle management of the VNF. On top of VNFs, on top of the whole stack, they introduced the concept of NFVO, the NFV orchestrator. And here there's a very important tip. The term orchestrator itself is not descriptive. What do I mean here? You can't say that, we have an orchestrator, we need an orchestrator. No, you have to say exactly what are you orchestrating. So here, that's an NFV orchestrator. It's only on the environment of NFV. So it is doing what we call resource orchestration and service orchestration. We will come to that in the next sessions. But that orchestrator, for instance, doesn't understand the voice quality. For example, if you are hosting an IMS, this NFVO will never see the voice quality. Will never take any metrics from the SQM, which is the service quality, whatever. So there is an orchestrator for each domain. That's why it makes sense. For example, when you go to radio, you say, I have a RAN orchestrator or RAN domain orchestrator. I have a cloud orchestrator. I have a network orchestrator. So the orchestrator is a buzzword. It has to be used with the right context. So here we're talking about the NFV orchestrator that was introduced by HCNFV to do orchestration within the context of HCNFV architecture. Okay. Last thing, the EMS and the OSS/BSS, that's actually classically the telco stack. Any kind of network function or VNF, most probably it is managed by an element management system, like U2000, like Cisco Prime, and other solutions from Nokia. So each element, each network function has an element management system doing what we call the FCAPs. FCAPs, usually, it's like the fault management, the configuration, accounting, performance management, and security. So each vendor comes with his own EMS. And usually in telcos, most of us all know that, they have the umbrella of OSS, BSS, taking feeds and governing the operation of these EMS. So EMS and OSS, BSS, this is actually a classic bricks of the telco enterprise, not related really to HCNFV. Okay, so that was the reference architecture in 2012. And as you see, there is interfaces and reference point. For example, if you go to VNFM and NFV orchestrator, that's the OR VNFM reference point. And from that reference point, if you go to the standardization of the standards of HCNFV, you will know what kind of interfaces are there in the reference point, what kind of processes are there, and you can go even to the level of APIs. Okay, so this is how HCNFV are organized, and we will have some time to go together and try to get some information from the standards. We will have more focused session on in these functional blocks in the next sessions. But for the time being, I just want to tell you that there is a reference architecture. There are new functional blocks were introduced by HCNFV, and that's how most of the operators started their journey, by trying to build a cloud tuned and aligned to this reference architecture. Okay? HCNFV didn't stop from that time, and the stack grew. And now we have more sophisticated, not sophisticated, but more dense and a stack that actually copes with the technologies. For example, new functional blocks are there now, something called CISM, CIR, and CCM, and that accounts for the containerization part. We will not go into that, but HCNFV architecture is very similar to the concept of 3GPP architecture. Like you have an architecture for 3G, and then with the evolution of technology, you go 4G and 5G, the stack itself evolves. But the question is, do operators now follow strictly, adopt the HCNFV architecture the same way they do with 3GPP? The answer is transparently no. It's not like that. And we will talk about that point, because in cloud, in virtualization, in automation, and orchestration, there is a space for innovation. There is a space for making your own stack to fulfill your own use cases. You don't have strictly to follow a specific standard like 3GPP, because the lesson learned from the duration of 2015 till 2018, some operators, they felt that it's very difficult to stick or to align to a specific reference architecture. And that's why many operators, they actually they went far beyond the HC NFV architecture, and now they are starting to do their own stacks aligned to other blueprints or aligned to their, for example, partnerships with different vendors. So I just wanted to give you the look and feel on how the HC NFV was formed, what is the NFV technology, what is the reference architecture, how did we start, and how now we are, and how we ended, because that's the latest architecture that HC NFV is doing. And as I said, we will have more sessions to go into the functional blocks of this architecture and actually assess the applicability and the adoption of this reference architecture in the modern deployments of the telcos. I have 3 slides, and then I will open window for questions. Now I'm going to focus on the NFVI, on the virtualization layer. And virtualization layer, that's the standard name of HC NFV to describe the concept of hypervisor. Okay. So we spent some time last session talking about the compute resources, the CPU resources, the concept of thread and hyper-threading. But how you are going to virtualize these resources and assign these resources to virtual machines, this is the function of hypervisor. Okay, so hypervisor is typically partitioning the hardware resources of a server. So if in a classic server, you have a number of CPUs, you have a number of disks for storage, you have a NIC, network interface cards. So hypervisor partition these resources and assign the virtual aspect of these resources, like virtual compute, vCPU, virtual disk, and virtual NIC, and networking, virtual networking to virtual machine. So when I read now the definition that hypervisor is responsible of abstraction and logical partitioning of hardware resources, yes, true. And then hypervisor provide these virtual resources to be consumed by VNS. Let me just admit to Rana. Okay. So in that case, the virtual machines will never have direct access to the hardware environments or to the hardware resources. So there's a hypervisor in the middle that is actually abstracting or decoupling the application, the virtual machines, and their guest operating systems from the hardware resource. And he's the one in the middle, he's the manager of the middle, understanding the requirements of the virtual machines that he's creating, and then assigning the logical resources or the virtualized resources to these virtual machines. The most well-known hypervisors are the KVM and E6i. The one E6i is one used by VMware solutions, and the KVM are the one used, for example, in Red Hat and OpenStack solutions. So this is the hypervisor, and hypervisor is actually installed, that's a good tip, on the server level. On the server, so each server will have a hypervisor. Okay, so we are virtualizing the server resources to an extent that some professionals in the IT, when they tell you that I have 3 hypervisors, sometimes they say that he means that he has 3 servers. So that's the word he says. A server is a hypervisor. Okay? There are 2 types of hypervisors. There are 2 types of hypervisors. One is the native, one is the hosted, or type 1 or type 2. Okay? Type 2, let's start by type 2, which is the easy one. Type 2 is actually the one that you use in your laptop or PC. For instance, I have a Mac OS. I have a MacBook laptop. So I'm having a Mac operating system. I cannot run Windows, right? Then I host a virtual box, which is the application or a hypervisor application that actually allows me to install the Windows images and have a Windows machine. So that means that hypervisor for the operating system for the macOS, it's an application. That's what's called hosted. And that's the I would say the commercial hypervisor used by individuals, maybe by some use cases, but it's not, I didn't see it in the telco. Telco, we don't use it. On servers, we use type 1 or the native. The native in the sense that, for example, the KVM. The KVM actually itself, it is part of the Linux operating system. So when you install Linux operating system with the right libraries, you get KVM on the kernel space. So it is part of the distribution, part of the operating system. That's why it is native to the operating system. And that actually somehow decreases the kind of translations needed to execute a certain transaction or a certain activity from the application. Instead of translating from hypervisor to host OS to hardware. So when the hypervisor is native, that gives better performance. So hypervisor, again, it is the software that partition the physical resource, okay, and creating the virtual machines and assign these resources to that virtual machines in the context of virtualization. And we in the telco, we are using type 1, KVM and ESXi, the two most popular. KVM, like OpenStack distributions, OpenStack solutions, Red Hat, Mirantis, Canonical, whatever. ESXi, the one used, famously used in the VMware, most probably most of the IT deployments are based on ESXi. So this is the two types of hypervisors. My last slide here is actually the virtual machine. The virtual machine, actually, it is the one that is created by hypervisor, and it behaves pretty much like a server. So if you are in a server, physical server, classically, one application would capitalize on that server providing a certain service. But with the existence of hypervisor, you can create multiple virtual machines, which behaves likely like servers. So you have multiple virtual servers, okay? And you can deploy multiple applications on each virtual machine. Every application, every guest, what we call guest operating system on that virtual machine will always think that he has a physical server. Why? Because the VM has the same ingredients like any physical server has. If the server has CPU, then VM also has a CPU. Server has network interface card, virtual machines has NIC cards. Server has disk, VMs has disk. But in reality, these resources are virtualized. But the existence of, or the role of hypervisor to actually to give these resources or to allocate these resources to the virtual machine. And that's what makes the virtual machine thinks that I'm a server, and the application is actually having a server, okay? Once we say VM, there is a term that is actually always come with a VM, which is the VM flavor. You always hear that in the context of when you do dimensioning, when you do planning, design. And the question is, what is the VM flavor? The VM flavor is actually what kind of CPU and memory and disk required by this VM to function or to do whatever logic. And it is the same flavor of the server, like the CPU and memory and disk. So you get from telco vendors or from the vendors their VM requirements in terms of flavors. He tells you, okay, my application require 4 VMs, and the VM flavor is 12 CPU, 12 gigabyte memory, and whatever the block storage or disk. So this is the flavor of the VM. And the role of hypervisor is to allocate these resources to the virtual machine. How does it do that? It does do that by interacting with the hardware resources layer, doing this kind of partitioning, and assigning these partitioned resources into the different virtual machines. Who actually instructs the hypervisor to do that? You remember the VIM, the virtualized infrastructure manager, this kind of VMware controller, this kind of OpenStack controller. So OpenStack controller, it is the brain. So if you ask OpenStack to, for example, I need to instantiate 4 virtual machines. So OpenStack, based on specific logics, specific criteria, he'll say, okay, I will instantiate 2 VMs on hypervisor 1 and 2 VMs on hypervisor 3. And these are the flavors of the VMs. And you know what? I will put the first virtual machine in NUMA 0, the second virtual machine in NUMA 1, in server 1, and in hypervisor 3, I will do the same. So OpenStack makes the logic, create the command, and send it to hypervisor, and hypervisor execute. So that's the case in telco. So the controller or the VIM are the one who making the decision which hypervisor to be used, and any kind of placement criteria, and then makes the right command that hypervisor understand and send it to hypervisor to execute. And then hypervisor instantiate the virtual machine with the orders that was instructed by the OpenStack or VMware or whatever controller or whatever VM, whatever VIM. Any questions?
Yes, Kareem. I don't know if this will be later in the discussion or not, but where is the role of the VCD with the VNF manager here?
Is it the director?
Yeah, vCloud Director.
Okay, so vCloud Director is a product, right, from VMware.
Okay.
So I'm going to talk about products, but I'm going to emphasize the role of VIM, and if there is some sort of a manager on top of the VIM, like manager of the managers, I will explain that. So it will implicitly map to VCD.
Yeah, okay.
Any other questions?
Kareem, I have just a question for, so all the applications or the VNFs are sharing the same, which are sharing the same NFVI, will have dependencies on each other since they are sharing, right, the resources. So they have to move together.
Okay, so NFVI is just a logical term. It can be, for example, 5 data centers with hundreds of.
But if we're talking about one infrastructure, right?
So in a pure cloud stack, like if you are really working on cloud principles, yes, they should share the resources. But in reality, because of the nature of the telco workloads, so sometimes you do some sort of partitioning. Like, for example, you assign specific threads to a specific VNF and other threads pinned to other VNFs, so that you guarantee that these VNFs will never intersect or will never have any kind of dependency. So in telco cloud, and that's what one of the not the bad things, but one of the symptoms of the telco cloud in the first 5 years, that they partitioned the hardware, but they gave the resources exclusively to VNFs, and they put quotas, and they did their best to make sure that no VNFs are actually sharing resources in reality.
Which defeat the concept, right? Okay.
If you wanted to say it from a negative perspective, then yes. But in telco clouds, private clouds, the most important is the satisfaction of the internal customers, which are the VNF owners. That you don't lose, for example, or you don't get the KPIs impacted of the CS because of a spike that happened on the packet core. So this kind of segregation was able to give the internal customer the satisfaction that they are looking for. But yes, you're completely right that if we assign specific resources very aggressively to each VNFs, yes, that violates the concept of the cloud, and we will discuss that.
Thank you.
Yes, Karim, I have one question with related to the vendor of HVNFM or VNO, which is the orchestrator or the infrastructure manager. Is it vendor specific? So each vendor has its own virtualization manager or orchestrator, which is managing their own component, or it is generic. And some of the VNF managers can control any kind of virtual machines. It is not related to any specific vendor.
Okay, so classically, away from the theories, the first generation was actually the telco vendors. They came with their VNF and their specific VNFM. So each VNF has its own VNFM. Maybe one vendor can have multiple network functions or multiple VNFs, and then one VNFM from that specific vendor can manage the three of them. Okay, but the concept of generic VNFM, that you have one VNFM manage all VNFs, has been always there in theory, and it was brought to real life when you started to host VNFs that doesn't have, or that don't have a VNF manager. For example, load balancers, firewalls. These vendors initially, they didn't care a lot to adhere to HCNFV and to create something called VNF manager. And by that time, like F5, the firewalls, Palo Alto, these kind of things, they didn't have a VNF manager. Some DPI solutions, they don't have a VNF manager. In that case, it makes sense to have one generic VNFM to manage all these VNFs. And this is actually happening, and that contribution comes from the vendors who only work on the orchestration arena. Yani for instance, players like Blue Planet or Sienna or Netcracker, they don't have a VNFs, but they provide generic VNFMs. So it makes sense to introduce these vendors to manage the VNFs that doesn't have VNF manager. So the two concepts exist: specific VNFM, which is a classic case for telco vendors to come with their specific VNFM, and also to have a generic VNFM. It is there for the VNFs that don't have a VNFM. The NFVO, which is the umbrella for the stack, it shouldn't be coupled with any application. You should pick the best of breed, the best supplier that actually has focused on the orchestration. So you can get many vendors in the market, and also telco vendors, they have their own solution, but NFVO is not coupled at all with the VNFs or any application. Especially if you see the stack, the OR VNFM reference point is one of the most mature reference point or interface between functional blocks in HCNFV. It was difficult at the beginning, but many of the colleagues here, they understand that integration NFVO with multiple VNFMs, it is doable. I mean, it is happening in a way or another. Okay. Does this answer the question?
Great. Yes. Thanks a lot, Karim. Really appreciate it.
Okay, so let's have like 3 light slides. We go now and see like top, bottom. So when we say cloud, okay, cloud can span across multiple locations. And when we say locations, the term always used is data center. Okay, so data center is where you host your servers, your computational power, your storage and networking. That's where you onboard your application. So that's based on data centers. Formerly, most of the operators were using the term site. That's the trending term by the time of 3G and even the starting of 4G. That we have core sites, regional sites, and colleagues here working on the operators and vendors, they know that. So I just wanted to give you the mapping, because you will hear a lot of terms about central, regional, and I made here the mapping. First of all, we have two concepts of core sites and regional sites. Okay, and you may hear the term core or regional, but initially, classically, where your core functions is located, that's where your central DCs are located. That's the classic equation. So see the initial core function that you had, for example, the CS network, the central core network, the gateways where you have internet access, I mean, to the internet, that usually takes the term central DC, okay? So either you call it central DC, core site, central DC, or national DC. Usually these terms refer to the main sites that have your core elements. Okay, and then if you go one step, I would say lower, you go to a concept called the regional DC or regional core sites. That's where you start to distribute your infrastructure or your sites or whatever. And for instance, in Egypt, like because many colleagues are from Egypt, if you stay away from Cairo and then you go to Alexandria, to Upper Egypt, to Aswan or whatever, so sometimes this can be called regional DC. If your country is based on a specific region, so you put a DC at each region to serve that region. So you get central DCs and regional DC. Below that, you start to hear the new terms, which is the edge. Okay. So there are some buzzwords or trending words like near edge, far or deep edge, enterprise edge, device edge. And here there is a tip. Okay. In telco, we have two types of terms. I just studied to make this kind of classification. I hope I hope it makes sense. Let me just admit chumps. Sorry. Let me admit how much chumps. So there are two terms: standard terms and community terms. Standard terms are the terms that are coming from standardization bodies, from 3GPP. When 3GPP, for example, says RAN, then there is a definition on what is RAN. When each NFV says NFVI, then there is a definition for NFVI. But there are some community terms that being used by vendors, by suppliers, by operators, by influencers. And the edge terms are all community terms. So when someone says near edge or deep edge, you have to ask him, what do you mean exactly by that? So I make this kind of mapping based on my experience and based on what I met, or what I found in the meetings with the customers and with the partners. So usually when someone says near edge, this is usually in telecom means that you leave the regional or the core sites and you go to the aggregation. So it's one hop under the regional. And aggregation, that's usually when you have this OLT grouping all the transmission or the transport coming from the cell sites. So that's the near edge. Okay. But again, it's a community term. So maybe someone said near edge and he means something else, but that's most probably to a big extent, this is the mapping. Near edge is like more into the aggregation and the OLT. Far edge, deep edge, a community term that usually used to describe going to the cell site. If you are going to put some sort of a service or a computational power or a specific server into the cell site, then that's the far or deep edge. And usually the combination of these two, the near edge and the far edge, or the OLT and the cell site, usually some communities refer to that with provider or telco edge. Okay. If you go deeper, okay, there is a concept of enterprise edge. And enterprise edge usually refer to the solution of providing a specific server or a specific device to a certain enterprise customer with some onboarded applications ready to use, like private 5G, and also here the concept of universal CPE, the one that Mu'tasim was explaining in the second session. Sometimes some operators, they call that enterprise edge. One of the operators in the Gulf, for example, it's business offering in the marketing message, it's called enterprise edge. And then in that offering, he provides a universal CPE, customer premises equipment, to the enterprise customer. And some others use the term device edge, which actually mainly the IoT terminal or the IoT peripheral or even the universal CPE. So this is just a mapping between the concept of data centers and the other POPs location in the telco, and also because data centers, that's where the cloud is hosted. So when you see now central, regional, near, far, enterprise, device edge, so cloud can exist in any level of these. It can be a cloud in a central DC. It can be a very micro cloud virtualized environment on a universal CPE. So cloud applies for all. You can have a huge cloud investment in the core sites, and you can have like a mini stack in a device edge or in an enterprise edge. Clear?
Kareem,
Yes.
can this apply to private and public cloud?
Okay, so I'm here mainly talking about private cloud. However, now in the days, public cloud, they partner with telco operators, and actually they help them to build like on-site stack. Okay, so for example, Microsoft and Salat, they are partnering for Enterprise Edge. Okay, and on the other way around, Verizon and AWS, Verizon actually is using AWS Web Lens, which is the AWS solution on the edge. So there is a hybrid offering between these two. So, but here it's strictly or identically matched to private clouds, but public clouds also they have some interference with that, and they have some correlation.
Okay, thank you, Kareem.
Kareem, regarding the near edge is near to the regional, yeah, between the regional and central, or between the regional and far. Something like aggregation, right? Aggregation.
See, near it is the aggregation.
Okay.
And again, it's a community term, so it's not a standard term. And my impression that it was called near edge because it is the nearest one to the regional size.
Okay. So it's like aggregation of many far edge to be.
Yes.
Yeah. Okay.
Kareem, what about tenant? I hear this terms used heavily in
Tenant.
yes.
Yes, tenant actually is when you segregate your cloud environment into tenants. For example, if you are hosting network functions from IMS team and network functions from packet core team and CS team and VAS team. So you create 4 tenants. And under each tenant, you assign a quota, for instance. Like IMS will not take more than 30 CPU. Okay, and also the administrator of IMS, when he logs in, he gets access to that tenant only. So that's the way you do some sort of security stuff and segregation of resources into different entities. You give them tenants, and sometimes they use the term project. And I collect all these things, and next sessions I'll also try to focus on these concepts.
Is tenant similar to an instance, or it's different?
No, tenant is actually segregation of the infrastructure itself. So you can get multiple instances of virtual machines, for instance, under one tenant. So tenant is an administrative instance that belongs to IMS, to CS, to whatever. But the term instance itself, sometimes it is used to describe the virtual machine itself or a VNF, okay? But here I'm talking about administrative instance, like a team or entity. You give them a tenant on your cloud. So they only see their tenant.
So under a tenant can be multiple instances,
Yes,
right?
yes.
Okay. Thank you.
Yes, Kareem. Maybe here there is some. It will be confusion between tenants and network slicing. I think they are different for sure. But maybe you can elaborate more.
Yes, slicing. It may come. I can cover that in the 5G use cases. And tenant is just a pure like cloud thing that's being used in OpenStack, for instance. So it is different from network slicing. Slicing is a 5G concept, and that can be covered later. Okay.
Yes, thank you. Thank you.
Yes, Kareem.
Please.
Yes, Jadala, one question. For each tenant, you need a VNF manager, or one VNF manager will handle the task for all of these tenants?
VNF manager cares about the VNFs. So for instance, if you have 3 VNFs from Ericsson, okay, and those VNFs, for some reasons, they were created in 3 different instances, 3 different tenants on the your data center, tenant 1, tenant 2, tenant 3, then VNFM will manage all these VNFs. If these VNFs are all in one tenant, then still VNF manager will manage the VNF. So VNFM is actually sees the corresponding VNFs. So if these VNFs are grouped in one tenant, then VNFM will only see this tenant. You know
Excellent.
what I mean?
Yes.
Okay.
Yeah. Thank you, Kareem.
Okay. So we have 2 slides. So what we were describing, and the whole concept of NFV, NFV, were all based on a service delivery model of a cloud. I mean, the cloud itself is characterized by what we call service delivery models. What are the delivery models of the cloud? What we have just seen is a classic delivery model of something called infrastructure as a service, or sometimes some people say IaaS. Infrastructure as a service means that cloud is only responsible, okay, to provide infrastructure for the user or for the application, in the sense that you tell me as an user what kind of VMs you require, how many VMs, what is the CPU requirements, what is the memory, what is the disk, which is the flavor of the VM, and me as a cloud, I'm only responsible of giving you the virtual machine with the infrastructure requirement that you ask. And then you, as a telco function owner or a user or whatever, you can just go and do whatever you want. You install IMS system, you make it work as a packet gateway, firewall. We at the cloud, we don't care. As long as we gave you the VMs with the connectivity that you required, all infrastructure stuff, then we are fine. And that's NFV was focusing on, what NFV was focusing on the first 5 years. And this is classically currently what is the telco clouds are offering, private telco clouds are offering in the operator. Just a virtual machine, an infrastructure as a service. Okay? That's the very logical representation of a telco stack, that you have compute power, hundreds of servers, different data centers. You have storage, number of disks in a certain way. You have a network capability, like, for example, the switches, NIC cards, whatever. And then you virtualize these resources and provide virtual machines for telco VNFs. That's the infrastructure as a service. And on top of that, you have maybe some controllers like OpenStack, VMware, VNFM, NFVO. You have some automation stuff. You can automate some steps. And you have an operational tools like something do fault management, performance management, whatever, logging, whatever. And that's a mini cloud stack that most of the operators are trying to build or tried to build based on NFV. Okay, so is the concept of infrastructure as a service clear or not?
Yes, it's clear.
Okay, so basically, if the application was IMS or voice over LTE or whatever, and then the voice quality has changed, or there is a degradation of voice quality, most probably the cloud or the infrastructure engineer, he doesn't care, because he doesn't see the application. He only provides infrastructure as a service. Okay? My last slide here, just to give you the look and feel of how the data center fabric or data center structure looks like. Okay? Just to cover that and maybe cover some buzzwords you may hear. So your cloud environment, mainly they are positioned in data centers, right? So in a certain data center, you create a cloud environment. We can call it, let's say, Cloud DC Instance 1. And that includes, for example, 50 servers that provide you the computational and networking and storage requirement. So you have 50 servers. So these servers will be placed or will be located in racks. Okay? And your applications or your VNFs will run on these servers. The professionals responsible of the networking, or data center networking, or cloud networking, or whatever MPLS, they are very interested to understand from the VNF vendor or team how the traffic will look like. For example, do you need an application in rack 1 to communicate with an application in rack 2? And here you start to see the term east-west communication. So they ask you, is there any communication east-west? Another question, do your applications that are located in racks, whatever, require an internet access? They will talk to the internet, or they talk to other services in other DCs. So they are very concerned about the east-west traffic and the south-north or north-south, or the traffic that actually traverse the data center. The structure that is actually adopted, commonly adopted, we call it spine leaf or leaf spine architecture, that have some sort of access layer, which is leaf switches. Leaf are switches from Cisco, from Juniper, from Ciena, from Huawei, from wherever. These are responsible of aggregating the uplinks from the servers from different tracks. And then they are all grouped into a spine, which is an advanced switch, can be layer 3 switch or powerful router. And then this spine is integrated to a data center gateway, which is responsible actually to do the routing and push it forward to the IP MPLS or the backbone of the mobile operator or whatever. So this kind of paradigm is called data center fabric, that includes the leaf and spine and data center gateway. Sometimes spine are combined with data center gateway as a product. Sometimes they can be an extra layer or something called border leaf from some vendors, but more or less the structure or the networking or what we call data center fabric or the underlay, sometimes we use the underlay term, it looks like that, a spine leaf architecture. You group racks into leaves, for sure, preserving the redundancy, and then you group the leaves into a spine, and then you go to the center gateway and go outside. Any kind of communication of a VNF to a VNF or a VM to VM, it will use the term overlay. Overlay, this means that it is like a service communication that happens over the data center fabric. Data center fabric for us, we call it underlay. That's the term you may always hear, the underlay, which is data center fabric. Overlay is the communication that is actually happening between the servers, and it has many flavors that can tunneling, whatever techniques. Okay? So our workloads, our virtual machines will always be hosted on these servers, and there will always be an ask that these VMs should communicate together, these VMs should communicate to outside, and that's come the techniques of the overlay, this kind of EVPN, BGP, and this kind of routing stuff that you always hear. Yeah, Philo?
Yes, I have a small question here to make sure I understand correctly. You were mentioning that some apps in a rack could want to communicate with other application in other racks.
Yes.
This is not related to the app itself. يعني, in other words, I mean the app could be hosted on different racks because we deal with the nodes, with the compute and storage as a one pool of resources, right? So one application could be hosted on different racks, right? Or no?
That's a very good question, Philo. So in a classic cloud deployment, if you don't govern or control that, yes, you may end up with your application itself structured into different tracks and different servers. But what we do in Telco Cloud, because we take the requirements from the application, and most probably they will always look for a kind of affinity that you have these applications at least running on the same rack to avoid that kind of traffic traversing the spines. So
Okay, so as a solution architect or cloud architect, I constrain apps to specific racks, right?
yes,
Or I could.
yes,
Okay.
yes, very good point. We have the techniques of VM placement. We call it VM, virtual machine placement, where to place the VM. And there are a lot of logics here. In Telco Cloud, there's some static stuff that we do to make sure that the VMs will reside on the same rack.
Okay, this is to minimize the traffic, right?
Yes, and also to not impact the performance, because maybe the vendor will tell you if my traffic will traverse the spines, this maybe may add a delay budget, for instance, and that will impact my serviceability. So that's why we do that.
Yes, okay, I understand. Thank you.
Okay, so any questions?
Karim, بس لو if you can explain the leaf function.
Okay, so usually in one rack there is like 2 leaves. Okay, these are like aggregating all the uplinks from the server. So all servers of the same rack, they have NIC cards or they have network ports integrated. I mean, the uplinks from these ports are going to the leaf. So leaf aggregates all these uplinks and then send one good trunk to spine with a very good bandwidth interface. What I'm saying that if you have your, for example, VNF components inside one rack, then you can do this kind of layer 2 connectivity using the leaf without the need to go to the spine, for instance. That's why leaf can do this kind of layer 2 communication into one rack, and also the group of the uplinks and then integrate to the spine. It's a switch.
And the spine, it's another switch.
Yeah, but it's
higher capabilities.
Usually it's level 3 capable. Yes. Tier 3. I will plan for a session where I'm going to invite like some professional in data center networking, and he can talk about the new trends and these kind of things. But more or less, this is the architecture adopted by most of the mobile operators.
Okay.
Jadallah?
Karim,
Yes, Karim. Sorry. Is it there? Just one question, Karim. Can we consider these 2 spines located at the same site, or this slide representing 2 different geographical locations?
No, this is intra DC. That's in one DC, in one geographical location.
In one DC. Okay, so we have 2 DC gateways and 2 spines.
Yes.
Okay, excellent. Thank you.
Karim, regarding the slide of ATC version 4, the main new concept here is the container, right?
Yes.
Yes. Okay. Thank you.
We will come to that. So with the containerization wave, HCNFV had to adapt. So it enlarged the reference architecture, having the new functional blocks that corresponds to something like Kubernetes and these kind of things.
Okay.
Okay. So last slide. We now understand more or less the infrastructure as a service model that Telco Cloud is providing by giving this kind of VMs. We want to take one step to see actually what the public cloud is doing in telecom, okay, like AWS, Microsoft, and Google. So there was one article in January. It was published by Light Reading. And as you see, the name, the title was a little bit shocking. It's called "The Public Cloud Has Failed to Crack Telecom." Despite all the cheerleading and hype, telcos remain fiercely resistant to putting their mission-critical workloads in the public cloud. Okay. And it generated a lot of debates, as I said, on LinkedIn. So the activity is, I want you to read the article. I put the link here. Just have one group call or group meeting with your group. Share your impressions. Okay. And if there's any kind of unclarity or you want to ask questions about this kind of article from business or technology perspective, then I'm hosting next week Michael Habib and Sharif Salim. Michael Habib, he's a tech sales lead in Accenture. And Sharif Salim, actually, he's the senior tech solution specialist in Microsoft. So both of them are working on that domain and integrating or bringing the hyperscalers into the telco landscape. And I need questions from your side, okay? Then please try to do that and send me your questions. Feel free also to share the impression of your group or the output of your meeting before next Wednesday. So Wednesday is the deadline. Okay? Or let me make it Thursday. So by end of the week. Thursday is actually the deadline. And then on Saturday, we're going to meet the guys. We have some questions already planned from my side, and I'll take your questions and have it part of the next session's interview. And the good thing that we are not, doing a marketing stuff and bringing some executive to talk about, bringing some buzzwords, these kind of things. Those people actually, they are in the field and they know, as I said, they can assess this article and even the role of hyperscalers from business and technology perspective. I think it will be very, very useful. So, I'm expecting that you share with me your questions by Thursday this week. Are we okay?
Okay. Yes, sure, Karim.
Okay, thank you.
Okay. How was today's session?
Great.
It's
Great.
very, actually.
Yeah, very good one.
Very good.
Yeah. Sorry.
Thanks a lot. Thank you so much for today.
Okay. Thanks a lot. Then I'll send the invitation for session 4, and again, it will be an interview with those guys. It's a very good practice. I will not have the invitation extended to the wider community. It will be only for us. So it's a safe space to ask any questions about strategy, about even clarity about the whole thing. It's a very safe space. So and the recorded session, it will be somehow edited, so you can just feel safe and feel to ask any question that you need. So thank you, and see you next week.
Thank you, Karim.
See you.
for
Thank
Thank you very much, Karim.
Thanks a lot.
Thank you,
Bye.
Karim.
Have a nice weekend.
Thanks a lot.
Thank you, Karim.
Bye.
Thank you, Karim.
Thank you.
So